Hello everyone, and welcome to this Druid Summit session. Today, I'll be talking about how Citrix uses Druid along with other technologies like Spark and machine learning to protect its 400,000 plus customers from security attacks. So I'm Arun Janathan, and I'm the architect for Analytics platform team at Citrix. With today's agenda, we'll start with a brief intro to Citrix and how Citrix Analytics fit within Citrix. Then we take a quick look into the security features covered by Citrix Analytics. After that, we take a deeper look into those features and into how those features are implemented and the role of Druid in delivering those features. Next, I share some of the performance issues we have faced. I share some of the performance issues we have faced, performance issues we face and the solution, and then follow it up with Druid resiliency design. At the end, I'll share our thoughts on Imply Druid and open up for questions. So Citrix at a glance. Work is no longer a place. Work used to be bound by physical building, devices, and even time, but not anymore. Work resources like apps and data can be hosted on premise, on cloud, and available via SaaS or web apps. Similar employee, similar employees are also distributed. Similarly, employees are also distributed. You can access these work resources from home, office, cafe, or while you're working from vacation spot. This means applications and information needs to be available whenever and wherever work needs to get done. And that is exactly what Citrix provides. So how Citrix does it, right? The Citrix Workspace platform is powered by two core components. Workspace infrastructure provides virtual desktops via VDI and DAS and is protected via access security module. App delivery uses application delivery controllers and SD-WANs to deliver an optimized app performance, and its application security module protects the apps and secures the APIs. So where exactly does Citrix Analytics fit in here? Citrix Analytics provides user behavior analytics and networking analytics by ingesting telemetry data from all Citrix products and using ML and other techniques to generate key security insights. These insights are then directly presented to customers and also used by access and app security modules to make intelligent decisions. So now let's look into the key security features. Here, for a given organization, this is one of the main security features provided by Citrix Analytics. We calculate a risk score for every single user within an organization. So these risk scores are calculated by what we call as risk indicators, and we will see those risk indicators in the next slide. As you can see, we show list top risky users over here. And if you click one of those risky users, we'll go in and you can see why the particular user was flagged risky. So here is the user risk timeline. In the user risk timeline, you can see this particular user logged on from a new device on the 25th, and that was marked as risky. And 2 days later, the user had 12 potential data exfiltration events. And at the bottom over here, which is not shown because it had more PII information, you can see it will tell you exactly the specific events that resulted in a data exfiltration alert. So, so, so we have this data exfiltration is a kind of risk indicator. Like that, we have multiple risk indicators. For example, we have an impossible travel indicator. Uh, uh, if an user logs on from San Francisco And 10 minutes later, the same user logs on from New York and something is fishy. We definitely erase an impossible travel indicator. And based on the indicator, you can decide whether to log out, log off with a user, or record the session of that user, or just put that user on a watch list. So you can take multiple actions based upon this risk indicators. So this is the other option we provide is provide our customers the ability to define their own risky events and take actions on them. As you can see here, the user can go in and create a condition, specific condition over here, and say if this condition ever happens, whether it happens first time, or whenever it happens, or it happens excessively, then let me raise an indicator. And the same, and the user can also go to the policy page and say, if this particular data exfiltration event happens, then log off the user. So the our customers have the power to define a particular condition, and then when the condition happens, take an action based on the condition. The last security feature I want to provide is a self-service search. Uh, Here, as the name indicates, we allow the users to do their own analysis. So we store the raw data in Druid and allow them to query the raw data. As you can see, we're not just giving the raw data, we're also providing more metadata about certain key columns. So they understand the data faster and can reach and can find the needle in the haystack they're looking for in a faster way. Next is how Druid enables Citrix Analytics. The Citrix Analytics platform, right? Citrix Analytics platform is made up of data, machine learning, and app platforms. It's a one-stop shop to build analytics solution. The boxes at the top are our internal teams, or data consumers, who build the data application on top of the platform. Let's take a deeper look. Let's follow the data as it flows through analytics platform. Citrix products send the data to our event hubs. From there, the data can take two paths. One is the streaming path, other one is the batch path. For now, let's consider the streaming path, right? So in the streaming ETL step, the raw data is streamed and augmented. The ETL data is then sent into the Kafka topic, and it is ready to be consumed by the product team. Product teams can write ML streaming applications, doing online training and inference, or they can write non-ML streaming applications. For example, they can join two huge teams to handle the Druid's limited join capability, or they can create risk indicators using the real-time rules engine and identify risky events. So these streaming applications, when they generate the insights, they write them back to another Kafka topic, which is then saved into the Druid using the Druid Kafka ingestion capability. So since this we're talking about security, and we want to react faster to any kind of security events, our internal SLA to generate insight is 1 minute latency. From the time the data arrives with the event hub, we should within the next 1 minute we should have generated some insights on that data and made it available for our users. Now coming back to the batch path, for jobs that is for complex ML jobs that can't be run in a real-time pipeline or real-time manner, we use batch application. We use the batch path. For non-critical apps like active use calculations, we also use the batch pipeline. The insights generated by the batch pipeline are then again loaded into Druid via Airflow's Druid operator. So just to give you a full picture, this is nothing to do with Druid, but we also anonymize our data and send it to a data exploration lake so we can do our ML development on top of that anonymized data. So this next slide is still continuing the flow with the last slide. Now the data here in Druid, now the data is already in Druid, and the applications over here are ready to consume them. They do that by calling data service over here, which acts as a gateway to all Citrix Analytics data. As I mentioned in the start, we are a multi-tenant system with thousands of tenants. So multi-tenancy checks are required to make sure a tenant cannot read another tenant's data. The data service enforces this multi-tenancy check by making sure the incoming query has exactly one tenant. In the var, it exactly has one tenant in the var clause and is the correct tenant name. In addition, data service also implements a full-blown access control mechanism, the rate limiting, pseudo-anonymization, masking, etc. Now, let's take a look at the flow at the bottom over here, right? So, just storing the insights in Druid and showing them via UI is not enough. We have to act on those insights. The alert listener service over here listens to the various events like risk indicators. And when an alert is received, it calls Druid via data service to get more relevant information about that event and that creates the event report and sends it to the alert processing service. Now, alert processing service has all the information to process that alert. It the alert processing service enforces all the relevant actions defined by the user for that alert. So the action might be, calling the corresponding Citrix product and asking them to log off the user or start a session recording event and so on. Or they can send an email to the user asking, "Hey, we saw something funny. Is this you?" Or you can also send the event to the to the customer's own webhooks or where the SIM integration tools they might have. So they are aware of that. So that particular data resides in their security database and is shown in their dashboards. So this is a high level flow of how we generate we ingest telemetry data, telemetry events, and we generate insights out of it, and how we show those insights and how we take actions on those insights. So Druid has been godsend for us, but we didn't start with Druid. During the initial stages, we were in a startup mode and wanted to iterate on features as fast as possible. So we ended up storing our data in a SQL database, but every tenant gets their own DB. So you can easily guess what happened next. Once more and more tenants started to use our service, the SQL DB was becoming a big thing. We have to create additional Spark jobs for it, even for simple aggregations, right? Which in Druid, you can it's just a JSON spec and the aggregations are done. You also have to we also created a separate data loading service, a common service, so not everyone has to write a code to load their data from Kafka to SQL DB. So scaling that data loading service as we get more and more client and more streaming apps, um, it it became a headache. The OLAP queries was also not performing well because SQL DB is not columnar store, the compression is not great, and the indexing we have to indexing strategy is complex. On top of that, the overall cost of the solution was too high, and this is too much changes. Sometimes we got a small amount of downtime, and we realized that we need a better solution. So we benchmarked a few databases, and Druid was a clear choice. So, in the previous slides, I showed you how we traditionally use Druid, right? Like we still use it mainly as a way to store the data and show the data to and use that and serve the queries that the user sends to us for the data. But we're gonna the next two slides. I'll talk about some not so common ways in a Druid is normally used. Uh, so we used Druid lookups for user correlation. I'll give a small explanation of what user correlation means here. We have multiple Citrix products sending data to platform. As you can, the problem is they don't have a common field to uniquely identify a user. As you can see, this table on the top corner here, share file is a Citrix component that sends data. Similarly, workspace app, gateway service. They all send events to Citrix Analytics platform. But each one of them have a different way to identify the same user. For example, all these three user identifier points to the same user, but share file sends it as an email address, workspace app sends it as a SAM account name, and gateway service as a AAA username. So what happens is we end up with three different user profiles instead of just one user profile. So this is a data accuracy problem, and we had to solve it. And we have a way to correlate these users during the ETL process over here. So when we correlate multiple user profiles, we need to change the user IDs to a common user ID, so that they remain a single user in our system. Unfortunately, by the time this correlation happens, we may have already stored these three different user identifiers in Druid. So, so after some time correlation happens, we realize they're all the same user. We need to go to Druid and update these values. And as you know, they can be spread across, like last 30 days or last 3 months of segments. While updating Druid is possible, it's not viable to frequently update these Druid segments because this is not a one-off thing. We might have to do updates, every 1 hour. So we instead of doing that, we use lookups to correlate these users. So we create a user lookup table, like see how all these three different user IDs point to the same username in the table over here. So we created this lookup table. We routinely refresh this lookup table, and we load it to Druid. In the data service, which is where all the queries come through data service. So we intercept all the queries, and we change the query to use the lookup. Instead of saying username, we will say lookup username. And then Druid does the lookup, and it shows all these three users as a single user. The problem is solved. So this was one of our biggest data quality nightmares, and Druid helped us out very easily. So the two different ways we do that is using Druid for initializing our Spark state and also for blue-green deployment. Okay, excuse me. So let me talk a little bit about both these scenarios. The first one about initializing the Spark state. Let's say the admin wants to. Let's say this is the admin over here. He wants us to alert whenever a user logs on from a new device. So what he does is he goes into our UI and create a condition. Says, hey, when event type is log on, device ID is new, then notify me. So what happens is when the condition is he submits it to the API, behind the scenes, the real-time rules engine creates a new Spark app. But this is not just a stateless Spark job, right? We need to know all the device ID the user have used in the past. So it's a stateful Spark app. And that's a historic state involved. We need to go load last 3 months of data from Druid and load it into the Spark application. And we created a framework to automatically do it from Druid whenever a new business entity is added into the system. So this is another way that Druid helps Citrix to achieve its goals. The blue-green deployment. So this is slightly everyone might be doing it, but let me just talk about how we do that in Citrix. So what happened was we need to change our IPT location database vendors, right? And we need to repopulate most of our data sources with this new location data. me most of our security database, security events has an IP address, which means they have a location column. Now we need to, so let's say we have like hundreds of data sources, and we need to go for all of the data sources, we need to go in and change the location value to a different value based because we just pushed the database vendor. So we can do it, we could easily backfill, we can rerun the whole streaming pipeline for the last 13 months, and we can create a new Druid table. We can backfill that table with all the last 13 months of data. But as you can imagine, it's very costly and it's also time consuming. So what we did was we simply loaded the whole database as a lookup table into the Druid and created a new ingestion task. And in the ingestion task, we specified a transform spec that looks up into this location DB and adds a new location fields. So we did face some performance problem in this approach, which I'll talk about later in our performance section. So that's the way. That's the different ways we use Druid with Citrix. Moving on. So let's look into some of the performance issues we faced and what we did about it. All right. Let me start by giving you some free advice. If you see a group by query, if you see group by queries running on high cardinality columns, uh, just go on a long vacation and let someone else deal with it. It's super hard to improve. They are very super hard to improve. It's a nightmare. So we had one such group by query, and the cardinality of the group by column was 3+ million values, right? So when we asked our client team, like, hey, can you change the granularity? If you do that, it will help us out a lot. They were like, no, man, we don't want to do that. So in retrospect, don't ask your client teams to help you out either. It never ends well. Anyhow, we tried multiple options, uh, like creating a separate data source for this particular large tenant. It didn't help. Secondary indexes, different segment sizes, none of them helped. So we want to take a peek under the covers, like, hey, what's happening? So we generated a flame graph. So this is the flame graph. As you can see, the top uh, the 70% of the execution time is taken by the concurrent grouper. As you know, the processing threads runs the queries on every segment and create intermediate results. Grouper merges these intermediate results and create the final result set and sends it to the broker, and sends it to the user. Right. So this grouper is taking too much time, and we thought, like, okay, how can we reduce the stress on this grouper? So the idea was to the, one school of thought was, let's reduce the number of aggregation in the select statement. Our select statement had around 15 or somewhere around 15 to 20 aggregations, because it was for a dashboard, and all the aggregations were on the same data set. So it made sense for us. It made sense for the client team to run them all in the same query. So we reduced it to 5 aggregations. Instead of 15, we brought down to 5, and the query was performing well. It was under 5. It was, I believe, under 5 seconds, and that was okay for a large complex query. Yeah. So, so that was the good news. The bad news was the number of uh, the number of similar complex queries now increased by 3x, because previously what was served by a single query, now you're serving it with 3 queries. So under the load increase, under the proper production load condition, we were losing the performance went back to 25 seconds, 30 seconds, and it didn't help at all. So so now the only option we had was increasing the compute, which will be like tantamount to accepting defeat. So we went to Imply and asked for help, right? So then Imply said, hey, we have something which will help you. And we have a new sampling function, which you can see over here. Yeah. So this sampling function will give you will give you a sub-second or 1 or 2 second response to query with 99% accuracy. So the team right now, the client team right now is okay with that, and we're testing it in our performance environment, and everything looks good so far. So this is how we handled a we handled a highly complex group query. So I thought this is something anyway, this is not a common use case, but if you face it without sharing your experience, would help whoever is facing it. So other performance tips, right? So when we started, we forgot to set the rejection time period for late data. Since the universe, since the universe was aligned against us, one of our data producers suddenly started sending massive amount of late data. Due to this, middle manager started creating numerous small segments and slowed the whole system down. Right, so which ended up in some downtime. Similarly, the next one was the blue-green deployment, if you remember. So here we loaded the whole database, which is like around 8 million events, lookup table. So when you load that, and if you load that lookup table on heap, then you obviously have problems with the frequent GC and limited heap. So the better option is to go off heap. Similarly, in a multi-tenant system, noisy neighbor is a common problem. But if you're trying to solve the noisy neighbor problem using query lanes, please be aware query lanes only control the broker threads, not the underlying processing threads. So a single noisy query can slip in and grab the majority of the processing threads and star other queries. So so I think we're running out of time. So let me just fasten things up. Now let's talk about the Druid uptime. We actually get around 99.99% Druid uptime, but I don't want to put it down because that's how we jinx things. So what's happening here is we have a most of the what we see is the cloud provider is the most of the time cloud provider is failing rather than Druid itself. For example, the VMs go down, or then there is an isolated network failure, which brings down one or a small percentage of our historicals. Right. So to reduce the blast radius of a minor network failure or a minor VM Kubernetes failure, we wanted to spread our VMs across the availability zones. We were initially worried about, hey, broker and historical are in two different data centers. Will it cause any performance issue? And it didn't. Uh, but there is also a large scale failure. I'm not talking about a full region failure, but we have seen our whole AKS clusters come down. Thankfully, not Druid, but other AKS clusters. So we wanted to protect ourselves from that. And so our solution was to create a hot standby Druid cluster in a separate region. So whenever when there's a first sign of trouble, you switch to a hot standby and you keep responding to queries. Obviously, there is a freshness problem because the hot standby is not ingesting any is the middle managers are switched off. They're only the historicals are up. So you only have last 1 hour of data is not there, and but within the next 30 minutes, once you make the hot standby active, it starts ingesting all the latest data and it comes up to speed. So what we learned was monitor everything and automate the switchover process. Also, disable auto compaction because the metadb is active and hot standby. If you define auto compaction in the primary grid cluster, it tries to do that in the secondary grid cluster and it fails. So this is the diagram I have for the hacking hot standby. I'm assuming I'm running out of time already, so I'll go on to the next slide. This is about Apache, how we went from Apache Druid to Imply. And I want to share my thoughts on it. So our main problems were Druid version upgrades and config updates. They were both time-consuming and complex. Once once we had Imply Manager, all those things became super easy to do. Similarly, Imply Clarity simplified our performance testing process and also our access to production data. So and saving the best for the last. Imply professional services are the best in business. And because of them, I don't think I will ever get a call, a PagerDuty alert in the midnight saying Druid is down, because they help us set it up in a very efficient way. Now I'll open up for questions if you have any.
Yeah, are there any questions for Arun? Thanks for your talk, Arun. Very, very helpful, very informative. Okay, we have one comment, amazing presentation, very good. I definitely agree. Any, Arun? I think that means that the presentation was perfect.
All right. Thanks a lot, folks. Thanks for joining this session.
Okay, we'll give it another few seconds if anybody like to enter a question into the chat window. All right. Okay. One question is, are 2 billion events per day aggregated?
Yes and no. It's no. The 2 billion events is raw events, not aggregated. But we also store our, that's the amount of data coming through our event hubs. But when we store the data, we store the raw data and also the aggregated events, and we have multiple copies of the multiple representation of the same data. So when it goes to Druid, it's somewhere close to 3 billion events per day is stored there. By next year, our estimates are the data will grow from 10 to 20 billion events per day.
Wow. Okay, that's a significant volume. All right. Thanks for clarifying. Great, scalable Druid. Okay. Any other questions for Arun while we have him? All right. Well, in that case, we'll wrap up. But thanks, Arun, for your wonderful presentation, and thanks everybody for attending. I hope you've enjoyed this day of Druid Summit, and have a good evening.